Hey, about two students, Mr. Yance. Hey, we're going to finish up Limnology notes today. So this will be the last day of notes for this section of freshwater ecosystems and lakes, ponds, rivers, things like that. So we talked a lot about chemical tests and what they show and how we can go out there and solve a problem. If we know what the problem is it a pH problem? Is it a dissolved oxygen problem? Is it a phosphate problem? And that is a really good way of improving water quality. Now, before you would do chemical tests, however, you could go out and do like what we call a biological parameter, which means you actually can go out there. And I wish if we have time, we'll go outside to the pond and we'll do a little exercise on this. I've done this with middle school classes before and other groups as well. And we look at something called benthic macroinvertebrates. What is a benthic macroinvertebrate? Benthic means they live on the bottom. They crawl upon or they attach themselves to the bottom. And they're a macroinvertebrate, which means I can see them without using a microscope. Okay. So what you do is you take nets out and you bang them around on cattails and lily pads, and you knock these poor little benthic macroinvertebrates off their perch. They drop the net, you dump them on a screen, and you start sorting through and see what's in there. Now, what we found is most benthics are aquatic insect larvae. They're stages of an insect's life cycle where they may not look anything like their adult form, like stoneflies, mayflies, castflies, dragonflies. They don't look like they're adults. But in a larva, they spend a lot of time in the water. And we also have other benthics like clams and snails and worms and things like that. Well, what we found is some of these things can only live in clean water, and some of them you can dump in your septic tank and they would thrive. So we came up with a classification group. Someone way smarter than me came up with this system, and they figured out that these benthics are great water indicators. We call this a PTI, pollution tolerance index. The WQI is the chemistry test we've talked about earlier notes. These guys, why do we use them? This is why. They're very sensitive to physical and chemical changes. Some of them are very sensitive. They live in the water sometimes up to 2 years before they become an adult insect. They can't escape pollution. They're kind of stuck there, and they're easy to collect. You put these four things together, they're a great thing to use to study water quality. So they came up with this thing called the PTI. And what the PTI does is an index that kind of tells you I have a problem with my water quality. So in other words, it's a rapid way. It's easy to do. You don't have to drag a bunch of chemical tests out there and spend lots of money. You get a net and a screen and you head out there and you just start looking what's living in there, right? So it's a really fast way to get information. The problem that the PTI has is it doesn't really tell you what the problem is, and it doesn't detect. It only detects moderate and severe pollution, not just some lesser forms of pollution. Okay, so what you do is you collect these guys, and you can see that they have different categories. Now, it doesn't mean that if I only find these guys, red-tailed maggots, yes, there is left-handed, right-handed snails, by the way, bloodworms, if I find these things, that my water's bad, because they can live in clean water too. But if I only find these guys and none of these, now I got issues, okay? Our pond has an abundance of these things. We find all the categories. And then what happens is then you have a little checkbox. And it doesn't matter if you find 1 or 30, okay? If you find one, you put a little check mark in here, okay? And then they have a weighing factor. Obviously, the ones that live in clean water have more of a weighing factor. The ones that live in bad water do not. And you add that up and you come up with a number, as you can see down here, and it tells you what's your water quality. And what you should see is the WQI and the PTI should match, okay? And our pond usually does. Our pond usually tests fair in around the 13, 14 range. It's not good water. It's not poor water. It's just kind of I wouldn't say you can't canoe, you can't fit, you can eat the fish out of there. You're not going to have a problem, but I wouldn't drink the water directly out of the pond either, right? So, which is true for most of our lakes. And that's what we do with that. It's kind of a fun test. Hopefully we get a chance to get out there and do some of this. And you can see how this would be very useful. So you would do this first, and then you say, oh, I got a problem. Then let's bring in the chemical tests, and let's see what the problem is, and then let's solve the problem, right? So that's basically what limnology is all about, is protecting our waterways. We don't want to have lakes, rivers, and streams that are polluted. We want to recreate. We want to fish. We want to swim. We want to do things on the lake. We want to do things in the river. I love canoeing and kayaking. We want to take care of these freshwater ecosystems, and the only way we're going to do that is by doing stuff like these PTIs and WQIs, and have people that are willing to go out there and say, let's see if we have a problem in the Elkhart River. Let's see if we have a problem on Lake Wawasee or the School Pond or Ingle Lake or whatever, right? Hey, as always, I hope that makes sense. We are done with this chapter. We are done with notes for the year, actually. Got a good ring to it. And I appreciate you guys. It's been a great year. I hope you guys go on to do great things. And hopefully some of you maybe pursue a avenue in science. We need more science people out there in lots of areas. So, hey, thanks for taking my class. It's been a privilege. And as always, if you got notes, shoot me an email. Have a good day and have a great rest of the year. See you. Bye.